Hey kids, it's me again. Okay, in this video, I'm going to teach you how to deal with annuities where payments vary arithmetically. Okay, let's start. Okay, to start our discussion, let's have the following assumptions. Okay, so we're going to use these assumptions in deriving formulas for annuities with payments in arithmetic progression. First assumption, payment period is the same as the interest conversion period. Okay, we have a video kung saan payment period and the interest conversion period differ. Okay, pero in this video, okay, so we assume that PP equals ICP. All right? The next assumption is the interest rate is constant. And finally, since we will be dealing with annuities where payments vary arithmetically, okay, we assume here that the payments are not of level amounts. So here, payment amounts differ. Okay, pero may pattern. Actually, the payments form an arithmetic progression. Okay, so let's consider an arithmetically increasing or decreasing annuity immediate. Let's consider this, okay? We have a general annuity immediate, okay, where the first payment is equal to P, and then the payments increase or decrease by this amount, Q, okay? Thereafter, for in periods, okay, where I is the effective rate of interest per period, okay? So we may consider this time diagram. Clearly, this is an annuity immediate, yeah? Okay, payments are made at the end of each period for n periods, okay? The first payment is P, the second payment is P plus Q, the third payment is P plus 2Q, okay? And so on, okay? I hope you recognize the pattern, okay? So having this time diagram, we have the following notes. First, of course, P is a positive amount. And then, what can you say if Q is positive? So, ibig sabihin, we have an arithmetically increasing annuity immediate. Yeah? Okay. And then, if we have Q less than 0, ibig sabihin, we have an arithmetically decreasing annuity immediate. So, it's okay to have a negative value for Q as long as the last payment here, okay, the P plus N minus 1Q stays positive. Okay? So to derive a very important formula, let's consider this time diagram again. Okay? We're going to get the present value of these payments. Okay? So let's have this, the encircled PV. Okay, this stands for the present value of this annuity. To get the present value of this annuity, we're going to carry each of these payments to time 0. Okay, let's do it one by one. Okay, so the first payment is P. Okay, how are we going to carry it to time 0? We multiply P by the discount factor V. So that's why we have PV. What about the second payment here? We have P plus Q. How are you going to carry it to time 0? So you multiply P plus Q by V squared. So that's why we have this. Okay? And so on. So what is going to be our last term here? Ito, the present value of the last payment here. So you're going to multiply this amount by V to the end. So we're going to have this. Okay? So again, to get the present value of this annuity, we do it one by one. Okay? And then, I want you to multiply both sides by 1 plus I, like this. Okay? So I multiply the encircled PV by 1 plus I. So we do it on the other side here. Okay? So 1 plus I times PV. Do you see, magka-cancel out yung V at saka 1 plus I? Because V is equal to 1 plus I raised to negative 1. Okay? So magka-cancel out yon. So we're just going to have P as our first term. Dito naman sa second term, if I multiply it by 1 plus I, yung V squared at saka 1 plus I, magka-cancel yung isang V. So I'm going to have P plus Q times V. And so on. Our last term here will become what? After multiplying this by 1 plus I, it becomes P plus N minus 1 Q V to the N minus 1. Right? Here. Now, I want you to get this. Okay? So, you get the difference of 1 plus I PV minus PV. Okay? If you do that, you're going to have I times PV. Right? What about the difference of the other side of the equation? Okay? So, kindly verify this expression. Okay? And now, okay, so I think I'm just going to group all the P's and all the Q's. So that's why we're going to have this. Okay? So itong dalawang P na to, pinag-group ko and I factored out P. Okay, so that's why we have P times 1 minus B to the N. At ito yung dalawang terms na may Q. And to finally get the present value of our annuity, you divide both sides by I. Okay, and let us see what will happen. Imagine nyo, we divide this by I. So it becomes 1 minus V to the N all over I. But what is that? A angle N. Alright? So that's why we have this. Okay, so we have PA angle N plus, dito naman, I factored out Q, and then we're going to have A angle N minus NV to the N all over I. Yung I na nanggaling dito. Alright? Okay. Let's have one important note here. So, sinulat ko ulit dito yung na-derive nating formula kanina. So, with this single formula, okay, you can solve any problems, annuity problems that involve series of payments that vary arithmetically. Okay? So, ganun ka-powerful ang formula na ito. Okay? So, better memorize this formula. Okay? Again, this is the formula in getting the present value of an annuity immediate with payments in arithmetic progression. So, what if I ask you the accumulated value? Do you know how to get it? All you have to do is to multiply the present value by 1 plus I raised to N, right? You just multiply the present value by the accumulation factor to be able to carry it to time N. Okay? What if I ask you to get the present value of an annuity due? Okay? With payments in arithmetic progression. Okay? Do you know what to do? You are going to multiply this present value here, okay, this single formula here by 1 plus I. Okay? If you recall the time diagrams, all you have to do is to carry the present value to the time when the first payment is made para maging annuity due siya. Okay? I hope that is clear. Okay? But even this formula can answer any annuity problems with payments in arithmetic progression. Okay? We still need to derive other formulas for actuarial symbol's sake. Right? Okay? Para pag nakita nyo yung mga actuarial symbols na yon, familiar kayo. Okay? So let me introduce you some actuarial symbols for increasing annuity immediate or decreasing annuity immediate. Again, we are focusing on annuity immediate here. Make sure that you can manipulate all the formulas for annuity immediate para magamit nyo siya for annuity due. Alright? Let's have an increasing annuity immediate first. Okay? So here, we consider the first payment is equal to 1. And then the amount of increase is equal to 1 also. So can you imagine how our time diagram will look like? Like this. Okay? So obviously, it is an increasing annuity immediate. Yeah? So yung formula na madiderive natin dito, pwede nyong gamitin if you have this kind of annuity. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Pwede rin 100, 200, 300, 400, 500, and so on. Okay? Pwede rin 200, 400, 600, 800, 1,000. Diba? So, ang gagawin lang natin dito is we recall our single formula and then sa-substitute lang natin ang value ni P at value ni Q. Ganun lang. Okay? So, let's do it. Like this. And then we simplify. Okay? Let's combine them into one fraction. Like this. You see it? Simplifying further, we're going to have this. Okay? So, parang pinagsama ko lang tong dalawang to and then I factored out A angle N. And then finally, what is 1 plus I times A angle N? It's like accumulating this A angle N to one period. So, it becomes A double dot angle N, right? Okay, so we have A double dot angle N minus NV to the N all over I. This is going to be our formula, okay, for an increasing annuity immediate. Okay? So, please take note of this actuarial symbol. Madali naman kasi I for increasing, A for annuity immediate. Okay? So, yeah, this one. Now, how are we going to get the accumulated value of an increasing annuity immediate? Okay, our notation is this one, IS angle N. Okay, so all we have to do is to multiply the IA angle N by 1 plus I raised to N, like this. So as long as you know the present value, you can easily get its accumulated value. Okay? Let's now have a decreasing annuity immediate. This time, we consider our first payment to be N and then Q to be a negative 1. Okay? So our time diagram looks like this. Pababa naman siya. Okay? So para siyang 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? Pwede rin siyang 500, 400, 300, 200, 100. Okay? So we are going to recall again our single formula for an annuity with payments in arithmetic progression. And then we substitute P equals N and Q equals negative 1. So we have this. So we simplify, we combine them into one fraction. Okay? So I write A angle N as 1 minus V to the N all over I para mag-cancel yung I na to at saka ito. Simplifying further, okay, canceling terms, you're going to have this. Okay? So this is our actuarial symbol for a decreasing annuity immediate. Okay? So this is the present value and this one is the accumulated value. So paano naman kapag annuity due? Okay? So that is easy because according to this note, all you have to do is to change I to D in the denominator of our IA angle N and DA angle N. Okay? Para magkaroon tayo ng formula para sa IA double dot angle N and DA double dot angle N. Of course, huwag nyo nang problemahin yung accumulated values. Kasi di ba, if you know the present values, di ba, mga present values to, all you have to do is to multiply this present values by 1 plus I raised to N. Okay, to get the corresponding accumulated values. And we have a second note here. Okay, what is the formula if we have a perpetuity immediate? All we have to do is to get the limit of our single formula as n approaches infinity, right? Like this. Okay, so if you recall, the limit of A angle N as n approaches infinity is 1 over I. Okay, so ito ay 1 over I. Yung A angle N dito, 1 over I. And then dito, it becomes N over 1 plus I raised to N. Okay? When you let N approach infinity, mas mabilis mag-grow yung nasa ilalim. So this expression becomes 0. Okay? So the present value of a perpetuity immediate with payments vary arithmetically is equal to this one. Okay, it's P over I plus Q over I squared. Again, this is for a perpetuity immediate. Okay? Iba kapag perpetuity due. Let's have some examples here. Okay? So first example, we have an annuity immediate, okay, that pays 20 per year for 10 years. Okay? So we have level payments of 20, okay, for the first 10 years. And then decreases by 1 unit per year for 19 years. And then in this problem, we use I equals 6%. We're going to find the present value of this annuity. Okay? To visualize this problem, make sure that you draw a time diagram. Okay? So your time diagram looks like this. You see it? Okay. So we get the present value. Of course, we use t equals 0 as our valuation date. So the present value is equal to, okay, so first, we consider these first 10 payments of 20. So it's like our basic annuity lamang. Okay, how do we get the present value of this 10 payments of 20? It's just equal to 20A angle 10, right? And then we have this kind of payments here. What do you notice? It is a decreasing annuity. Okay? And then how many payments do we have here? 19 payments. Okay? So we can have this one. Okay? DA angle 19 because we have a decreasing annuity. And why do we have V to the 10 here? Because your DA angle 19 is still at T equals 10. Yeah? Do you recall how do you rename a time diagram? Diba? Ito ay magiging 0. Ito yung 1, 2, and then 18, and then 19. So that's why nandito pa lang yung DA angle 19. So to be able to carry it to times 0, we multiply DA angle 19 by V to the 10. Alright? Or, if you don't like to use this actuarial symbol, this DA angle 19, you want to use our single formula, pwede naman. Ganito siya. This is how you get the present value. So, I just copied 20A angle 10 kasi parehas lang naman silang level payments of 20 for the first 10 years. Tapos, instead of using DA angle 19, dito, ginamit natin yung single formula where P is equal to 19 and your Q is equal to negative 1. Okay? Please get the numerical values here and make sure that they are equal. Okay? Let's have another problem. This time we have a perpetuity immediate. Okay? So, if you read the problem, you're going to have this time diagram. Okay, so for the first N years, we have an increasing annuity. Okay, after N years, yeah, level payments na. Okay, the level payment is equal to N plus 1. All right, okay, so what else are given? Okay, we're given 7.5% as the annual effective rate of interest, and we're also given this value. 150. This is the present value of the given perpetuity. Now, we are going to find the value of n. Okay? So, we need to set up an equation here. So, at time 0, the present value is equal to 150. Okay? So, we get the present value of these payments. Okay? So, for the first N years, we have an increasing annuity immediate. So that's why we have this. Okay? IA angle N. Again, if you don't like to use this actuarial symbol, you can always go back to our single formula, our PQ formula. Our P is 1 and then Q is also 1. All right? After getting the present value of the first N payments, we now get the present value of this perpetuity with level payments of n plus 1. Okay? So it's just n plus 1 over I. But you need to multiply it by v to the n, okay, so that you can carry it to time 0. So we have this. Okay? So solving for n, okay, you're going to solve for this value. Okay? So n is approximately 20 years. Please make sure that you can show that n is really approximately 20 years because it's a good exercise. Okay, I think that's it. I hope you learned something from this video. See you in my next video.